Hello, welcome to all. Myself, Dr. Sridhar Marchetti. I am a research fellow at Department of Civil Structural and Environmental Engineering, Trinity College Dublin, Ireland. And my co-authors are Sandeepan Patra and Malvika Basu, who are with Department of Electrical and Electronic Engineering at Technological University Dublin, Ireland. So today, our paper topic is about hardware-based intrusion detection in ELAN-based distributed DC microgrid, a virtual sensor approach. So the main aim of this paper is to detect the malicious attack done at the hardware level in a DC microgrid. So basically, when the DC microgrid interconnected with each other in a local area network, we are proposing a virtual sensor method through which we can not only detect but also correct the malicious activity. So the major objectives of our topic is to mathematical model a two-way Lundberger observer. So basically here we are using a Lundberger observer based estimation technique for uh, for 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 obtaining the false data injection, hijacking and sensor damage attacks. So we are also implementing the primary, secondary and tertiary control for DC bus voltage regulation and load sharing with the help of distributed cooperative technique using this method. Also, we are implementing the proposed system in real time with the three sources that are connected with each other, and I will show you how this system is getting connected. Further to that, various test cases has been uh, various test cases has been conducted for false data, sensor missing, sudden load changes, and its results are explored. So finally, and most importantly, this paper discusses how the proposed scheme can be easily expanded for the larger systems. So basically, in this system, you are able to see here, we are considering the three buses. This is bus number 1, bus number 2, and bus number 3. At the bus number 1, we are using a voltage source, and this voltage source is connected to a DC-DC converter, and in parallel with the voltage source we are using a virtual sensor. At the bus 2 we are also using a voltage source with bidirectional DC-DC converter, and we are also using a virtual sensor method here. At the bus 3 we are using a solar PV panel with a DC-DC converter, where we can find out the maximum power point tracking algorithm and at the same source. So basically these are the three sources that are interconnected with each other via the communication local area network, which you are able to see here. These are called energy local area network that we are calling. So this system further can be extended to n number of systems, that as informed earlier. So the basic structure of the system is like this. Primarily, we'll explain for the PV system, which is at bus 3. This is a PV array. This PV array is connected to a DC-DC boost converter, where it is it will boost the voltage from one level to other level, where the MPPT algorithm we are implementing, and there is a bus or a load is connected here. So in this PV array, the majorly what we are doing is we are sensing the voltage, and with the help of Lundberger observer we are estimating the current. So with the sensed voltage and with the estimated current, with the help of maximum power point tracking algorithm, we are obtaining the pulse, and from the pulse we are generating the pulse generator. That is first point number 1. And this point number 2 is we are taking the current and with the help of Lundberger observer we are estimating the voltage. From that we are giving it to MPPT controller. And so the most important thing here is we are also directly taking the voltage and current. From that we are also making an MPPT controller, where the maximum power point tracking algorithm will this maximum power point tracking algorithm will generate the pulses. The pulses generated by this, the pulses generated by the current estimation and voltage estimation will be compared, and then decides if it is within the tolerable range, then we'll declare that the system has, the attack has not been launched. In case the system is out of the threshold level, then we can declare that attack has been launched. So this is actually conducted at the bus number 3, where we are using the 3 modes of operation in the mode without any cyber attack, with cyber attack on current sensor, and with cyber attack on voltage sensor. Further, the system has been extended for the bidirectional DC-DC converter. So this is most important part of the exact paper. Here we are using a DC bus, or I can say this battery storage. This is connected to a bidirectional converter where it is having a switch Q1 and switch Q2, and it is connected to the DC bus. So from here, so we are having 2 estimators here. This is the most important. So we are having actual bus voltage we are comparing with the reference, and the error will be generated. That error is going to a PI controller, and from the PI controller the current reference will be generated, and we are actually taking the current from this from the inductor, and we are generating the error signal. So the important thing here is we are taking the duty as a feedback and V bus voltage as a input to the estimator, and we are generating the current. So the current that is taken at this inductor, the current generated by this estimator will be compared, and then decision will be taken and the error will be generated, and the further PWM pulses will be generated, and to switch the either the switch Q1 or switch Q2. In the similar way, in case, so this is executed in case if any fault is if in case of any attack is launched on the current sensor. If any attack is launched on the voltage sensor, so we are using the another loop. In this loop, what are we doing is we are taking the duty and the inductor current as the input, and we are estimating the voltage, and this voltage we are comparing with the bus voltage and actual voltage, and then further we are giving to PI, and then you are generating the duty. So this is how, like, even if any voltage sensor, if the attack is launched, or if the attack is launched on current sensor, we can able to easily identify the attack. Further to that, this has been this is basically designed on Lundberger observer mode, where just a small information thus I would like to give how the system has been designed. And here, say for example, if you have a system, dynamical system, where A and B are there, where x of k is the true state, with the help of the C we are getting y of k. So how are we estimating? So since we know the system A and B, we are taking the A and B here, we are estimating the x cap of k. So the dynamics of the real-time system can be taken as x of k plus 1 is equal to A into x of k plus B into U of k, and for estimated system, x cap of k plus 1 is equal to A into x cap of k plus B into U of k. So the error is x of k minus x cap of k can be put is something like this. The error x of k plus 1 is equal to A into x of k plus B into U of k minus A into x of k x cap of k minus B into U of k. So finally you will get A into x cap of k. So since that is open loop system and we wanted to use that as a closed loop system, in the closed loop system, having said the same process we are repeating here, except we are introducing a Lundberger gain of L. So this is the above first row is completely actually a system, second row is estimated system. So the actual output is compared with the estimated output, and this will be given as a feedback and with input to this Lundberger observer gain, and then we'll tune the value of L, and such that it will detect any of error. So this one we have the proposed scheme we have implemented with and without cyber attacking launching. So without cyber attack launching, you can able to see it's clearly the voltage, current and power signals for sudden change in the load as well. Now, so for example, if any cyber attack is launched, so if any deviation in the voltage is observed, that voltage you can see here, the cyber attack launched at bus 2, bus 3, or in all the cases the voltage is maintained constant. So hence, and there are so many other cases also that we have explained in the article. So we request you to go through the article, and if you have any questions, kindly revert us back. Thank you very much for giving this opportunity. If you have any questions, please reach out us at sridhar.803@gmail.com.